Hey everyone, welcome back to the channel. I am Nehemiah, and in the past I did a video like this and many of you liked it very much. Today I want to do something similar, and this is going to be for a project I worked on in the past for a client in Ghana, and you're going to love it, I promise. So let's start. So first things first, I want to again just make a quick check to make sure my audio and screens are okay. Okay, it sounds good. Please let me know in the chat if you can hear me. All right, so let's go ahead. So I'll talk about everything. Okay, I planned to talk about most of the details, and let us start with the requirements. So I'll simply underline this and then put. So we're going to deal with the requirements first. So always there are the functional requirements and non-functional requirements. I'm looking for a bigger print of this. So talk about the requirements. So the client needed a cloud-based asset management platform for their needs. And then on this other end, I can have the non-functional requirements. I think in the time we're living in, it's even more important to understand how to design systems. And the more you design systems, the better you get at it. Okay, so let's go ahead. And by the way, at the end, please let me know how you would design the system. Okay, this is how I designed it, but please share in the comments what you'd change, what you would remove, what you would probably, I don't know, modify and maybe do much better. I'll be really curious to learn from you. So the first thing, like I told you, we're going to talk about the requirements. The client wanted to have registration, so the application should be able to register users. That was one of the first things. So register. Okay, register users. Okay, and also register assets. That was also another important thing. So register users, register assets. Those are very, very, very key. And then something else that comes to mind, let me see, register assets. Okay. So of course, authentication is usually mandatory. Okay. Register assets. Sorry, my power had just gone out. I think I have a problem with the lighting, but it should be okay soon. Then after registering an asset, those assets are categorized. Okay. Another requirement was to categorize assets. Okay, categorize assets. And one thing I forgot to mention is that these are physical assets. Okay, physical assets. Okay, physical assets. So yeah, have that in mind. That here we are dealing with only physical assets. Okay, there is nothing maybe like maybe what can be an intangible asset, something like maybe the S&P 500, no, or a stock, an individual stock, nothing like that. Okay, only physical assets. That was made very, very, very clear by the client. Okay, after that, another requirement that they wanted was the well, I lost the pen. Okay, I've got it back. Another requirement was to schedule tasks. Okay, so every asset had a task. Okay, for example, let's say you have an asset which is a generator. Okay, maybe I should have put examples for you to understand what I meant by physical assets. So by physical assets, I meant things like generators. It could be a generator. This could be an asset. Or it could be, I don't know, an AC unit. Okay. It could be a vehicle. Okay. Among others, IT equipment. So the goal is for them to be able to register and categorize, okay, according to their categories. Then another requirement or function requirement is to be able to schedule tasks, okay? Schedule, but not only schedule, but also track, okay? So the goal was to schedule and track maintenance tasks. Maintenance tasks. That was an important requirement. And usually when you're building a system, you'd always, of course, want to uh, understand the requirements. Even before, by the way, I came to this conclusion, we had a chat, okay? I had a chat with the client and go to understand what exactly they wanted, okay? It's a number of conversations. We had about 4 conversations, then I had to document them, and then, yeah, they signed and accepted. All right. So schedule and track maintenance tasks against the assets. Then another requirement was to get notified before task due dates. Okay, I think it would be easier to type some of the things. Let me put here a box. Not that, but this text. Okay, I'll say you wanted to get notified. I'm going to expand this in a minute. Get notified before task due dates. So let me make this bigger. Okay, so this is bigger. So yeah, sorry you had me screaming to someone. So now after that, we are now done with everything. Sorry, I see. I quickly get interruptions in the background. You had me. I don't know if you guys had me screaming, but I think I had turned off my mic. If it misfired, I'm in so much trouble. You guys will clip me and push me all over social media. All right, another functional requirement. Let me edit this. Sorry. Apart from getting notified, they wanted to view dashboard reports. View dashboard reports. So to view dashboard reports, the goal was to have charts, okay? A chart showing things like a trend, okay? A weekly trend. Give us a weekly trend of what has been happening to the assets, okay? Have a report on the dashboard on overdue tasks, okay? Have a report, not a report, but a chart showing asset distribution, okay? And things like how many assets were created today, how many assets were created this month, this week, okay? By whom, okay? How many assets belong to this category you get. So these were some of the, then of course, one which I might have talked about earlier. Sorry, I need to select this, click on it, copy paste to duplicate it, and then drag it down. So the other one, of course, was to securely manage users, okay? And I mainly employed role-based access, okay? And audit trails, okay? Yeah, so these were the functional requirements. So now I want to now go into talking about the non-functional requirements. For the non-functional requirements, they are Also, by the way, if you have any questions before I continue, I'm going to keep looking at the chat from time to time. Okay. So do not hesitate to ask me any question. Okay. I like sharing my experience and teaching people what I've learned. Okay. I've discovered the more you teach things, the more you share your experience, the better you become. And the better you get an opportunity to learn from other people. Okay. Yeah. So let's carry on. Okay. So now what are the non-functional requirements? For this project, let me drag this aside. For this project, so I need to drag, I want to copy this and drag it this side so that I can only focus on the typing. Okay. So for the non-functional requirements, these are the non-functional requirements. Okay. The first thing was to have latency, okay, of less than, in the worst case scenario, okay, should be 500 milliseconds. Okay. And this is for the API responses. Okay. It's the first one. After that, the other was all about availability. Okay. The client wanted this project there to be 99%. Okay. Always up. Okay. So 99% uptime. Then the costs, they had a small budget, but for the hosting and everything, they wanted it to be as minimal, okay, as possible. They did not have a DevOps team, so they didn't want to have maybe complicated DevOps infrastructure and stuff like that. So they had a very minimal budget. Okay, wanted something minimal. Okay, I can just call it a startup budget. Okay, something minimal, a startup budget. Okay, and for the API, the goal was to have a pay-per-use. Okay, in case the API is idle, there should not be any cost attached. Okay, let me put this on the next line. How can I do this? Okay, that to be pay per use. So let me drag this so that the title can stick as I show you. Wow. I tried to select everything, but okay, this has now worked. All right, so what other non-functional requirement was there? Of course, security. That be secure. Okay. What else? It had to scale. Okay. The goal was to scale initially from around tens. Okay. Tens to hundreds. Okay. In case we needed thousands, then they said maybe they would call us back in case it did not survive. Okay. But for now, I think even it can scale even to 1,000. Okay. And I'm going to explain to you why I think it can scale to 1,000 or even to thousands. Okay. All right. Now that I've explained that, let me touch on now the high level architecture. Just to go through the high level architecture. So for the high level architecture, I need to go down here, duplicate this right there, and delete this and use a new color. So let's talk about the high level architecture. High dash level architecture. Okay, so because this is a title, I'll make it bigger. All right, so for the high level architecture, I'm going to split into two, okay? Two major components, okay? I would have the client layer. Let me put it here, okay? And then focus on the backend. Then we have the other layer here, okay? So, all right, so let's start. So for the client layer, I want to name them. So this is wow, I need a tool. Sorry, I need to drag this up here. So this is the client layer. Okay. So for the client layer, it was simply a single page application, okay, built using Next.js. I worked with a front-end developer on that, okay. For some time when they got sick for quite a long time, I was forced to actually integrate the API. So just a heads up for those who might encounter such experiences in their journey. But this is what happened. After that, the other backend, what I call the backend, okay. I will rename this here. It was simply something stacked on AWS. Okay, we built the backend mainly on using many components of AWS, and this was in the is it US West 1 region? Okay, I hope I can remember that properly, but it was, I think, US West. That's they call it it's EU. Okay, yeah, EU West. Okay, and mainly for the backend. Okay, we have first of all the API gateway. So I'll click on this. I want to use a different color. We had the API gateway as the first component, and this was the AWS API gateway. Okay, so requests, of course, via HTTPS, okay, come from the front end, okay, and what they first interact with is the API gateway. Can I write this better? It won't make sense if someone watching this cannot read. So this is the API gateway. Yeah, I think this is beta. Then I can wrap around this. Okay, so from the client to the API gateway first. Then I also had now the actual Django application. Okay, from the API gateway, the requests now go to the Django application. Okay, but this Django application was deployed to AWS Lambda. So I'll say we have another component of AWS called AWS Lambda. And I'm going to explain why we use AWS Lambda. In fact, I should even mention it now. Why wait? Okay. So we used AWS Lambda because number one, a traditional EC2 server would cost the client around like $30 to $50, okay, per month. And that's the minimum. Okay. But with the Lambda, which is serverless, it would be around $0 to $5 per month. Why zero? When when there's no request, okay, to your Lambda, and I mean to your application, and this application is being run via Lambda, and there's no request and it's just idle, you are not charged. Okay, so Lambda is a pay-per-use service. You only pay when requests are made. So for the fact of cost, okay, Lambda was top-notch for this. Okay, yeah, so we used Lambda. Okay, and how did we deploy to Lambda? Okay, we used a tool because our backend was built using Django. I built it using Django, and I forgot to tell you the team was actually we were a team of 4 people who worked on this. I, the backend developer, okay, another backend developer, a frontend developer, and management. And person was in charge of management and putting together the team and setting up other things concerning the client. So I'll say Django plus Zapper. Okay. So Zapper is a tool you can use to deploy Django applications to Lambda. If you're curious, I can simply Google and show you Django Zapper. Okay. Let me see. Okay. I'm going to expand so that you see. See, it says Zapper serverless Python. Where's the about? Okay. Says Zapper makes it super easy to build and deploy serverless event-driven Python applications, including but not limited to WSGI web apps on AWS Lambda plus API gateway. Okay. So it says think of it as serverless web hosting for your Python apps. That means infinite scaling, okay? Zero downtime, zero maintenance. That is why earlier on in the functional in the non-functional requirements, I told you it can even scale to thousands. Okay. Why? Because you can have infinite scaling, okay, and zero downtime and zero maintenance, okay, at a fraction of the cost of your current deployment. In fact, those of you who have been following me on this channel, I have another project which I've been working on. I am going to migrate it to Lambda very soon, okay? When all works according to my plan. All right. So I hope you understand and now appreciate AWS Lambda. Now, let me now move on to another component, but I want this to be nice. Let me draw it well. So yeah, this is the actual application, okay? Yeah, so if you're working with Python applications, yeah, try out Zapper, okay? You will not be disappointed. Trust me. Now, what else can we deal with, okay? Now, we had CloudWatch, okay? Let me see if I can fix it somewhere, okay? We had CloudWatch. Say CloudWatch. So we used CloudWatch for scheduled events. Think about CloudWatch as a cron job, okay, on AWS. So every day at midnight, okay, we run events, okay, at midnight. So our application had an interaction with CloudWatch, and I'm going to explain to you how this interaction happened. Then also we had another tool called RDS, okay, relational database management system for us, and the choice was Postgres. Okay, so this is just the high level architecture was Postgres. Then also we had SMTP email, okay, because we had a lot of functions of sending reminders, okay, using emails. Remember, I told you up here that we had users getting notified before task due dates, okay, and this was, by the way, it used two things. I forgot to tell you: SMS and also email. Okay, very, very important. Okay, what else can I see? What else comes to mind? I hope I've not left out anything. Yeah, so I hope this is making sense to you. Let me try to check. There's a document I had which I had designed for planning. I hope it has everything that I need. Let me see, just a moment. Yeah, I think that's it. If I remember any other component, then I will definitely share. Okay, but yeah, these are some of the components that come to my mind right now. Okay, so let me see what else. What else maybe can come to my mind? SMTP. Oh, we had bucket. We had a bucket. Okay, we used S3 for storing images and other static data. So S3 and an S3 bucket. How would I forget that? Guys who use AWS would wonder at me. How can you forget our favorite tool? Okay. Then now we can move on and go deeper. Okay. So like I was explaining to you why I chose Lambda. Okay. Maybe I can just explain a little more. Let me do this. Okay. And put here title saying why did I choose Lambda. And truth be told, I actually worked with my team. Some of these decisions, I didn't make them alone. So these are the reasons why I went with Lambda. Okay. My screen seems to be on low light. Let me try to increase it a little bit. Okay. I think this is okay. And there I am. I've lost the box I was typing in. Wow. Let me just create a new one. Okay. So why Lambda? First of all, it was the cost at low traffic was very good. Okay. Cost at low traffic. Okay. With something like EC2, you have to pay. Okay. It doesn't matter whether there's no request to your backend. Okay. Still you have to pay. But with serverless, once it is idle, you're not charged. Okay. It's a pay for every invocation. Okay. Then for scaling, for something like EC2, it is manual. Okay. You have to set up things like auto scaling groups and the like. Okay. But with Lambda, it's automatic, okay, and almost instant. That is something you should know. Automatic and almost instant. Then after that, this means that the ops overhead, okay, operation overhead is actually zero, okay. You don't need to manage any servers with Lambda, but with traditional EC2, you need SSH, you need to do patching, you need to monitor, okay, very okay, okay. Then for cold starts, I think this is where maybe EC2 can beat Lambda. Okay, but with Lambda, the cold starts are like between 2 to 5 seconds when they first hit, when you've been idle for a long time. But still, this was mitigated using Zappa. Zappa had a setting called keep warm in a number of configurations that you use to mitigate this. Okay, yeah. Then for region, for the region proximity, you can pick any. Okay, you can pick any. Yeah, but the whole goal is this. Okay, you have a client who's in Ghana. They don't have a DevOps team, but they need something that costs near zero when it is idle. But when users come online, okay, during business hours, like let us say from 8 a.m. maybe to 6 p.m. GMT, okay, it should scale. Okay, when users come online, it should scale according to the demand and number of requests. But when idle, it should cost near zero or even zero. So Lambda won in this case. Okay, I hope now you get it. Yeah. So I now need to talk about the decision that I took concerning the database. I should have numbered these things. So I'll just copy this and duplicate. Copy, duplicate. So I'll explain to you why PostgreSQL. Okay. Why Postgres? Okay. And then I can copy this, duplicate it, and then remove. Okay. So I'll tell you the options I considered. Okay. And Risk says, what are you building today? Can you give a brief? Good question. So, risk, I am talking about the system design and architecture for a backend, or rather a REST API I built for a client in Ghana. I've talked about several things. I've talked about the requirements. Okay. I've talked about the functional requirements and the non-functional requirements. For the requirements, you need to the the API should be able or was able, because it's not already being used. Okay. But at the time before I was given, okay, the task to do, these are the requirements. Okay. Register assets, categorize the assets, okay, schedule and track maintenance tasks against the assets. Okay. No, the user or clients had to get notified before a task due date via email and SMS. We needed to have dashboard reports, okay, and also securely manage users according to their roles. Okay. That is for the functional requirements. Then for the non-functional, low latency, in worst case scenario, should be 500 milliseconds for the API responses. Okay. Should be 99% always available. Okay. Minimal cost. Okay. Because it's a startup. Okay. And of course, security and should be able to scale from tens to hundreds of users. Risk, please let me know. That's okay. Then I went on to the high level architecture. Okay. Talk about the client layer that is sending requests to the to the API gateway, okay, on AWS. Okay. So requests don't go directly to the API, okay? They go through the gateway where certain things are done, okay? Like filtering the request, okay, knowing who is this person, okay? Are they allowed? Okay, things like that. Then after that, you have our AWS Lambda application, okay, which is a Django application, and we deployed it using Zappa. And this Zappa application has, okay, interaction with an RDS database, okay, which is a Postgres database. Okay, I think I might be back. Wow, I hate these disruptions. I don't know why. Okay, I am back. Please let me know. Riz, can you see me? Can you hear me? Please confirm in the chat. Okay, looks like I'm now back online. Wow, this is very ugly. Sorry. Sorry. Can you now please confirm one more time? Wow. Wow. All right, I think I'm back. Wow, that was ugly. I've never faced this before. I will have to edit this video after. All right, guys, please confirm. Riska is still here. Wow, wow. I've had over 100 live streams, and I've never faced this kind of challenge before. So I had to quit OBS. Can you imagine? Like I did a force quit, then I had to rebroadcast the stream from OBS. One guy who used to do CSS used to crack a joke and say, sometimes OBS can force you to. It's crazy. Sorry. All right. Please confirm in the chat. Can you hear me? Is everything good? I need to do a recap again. Then we can continue. Please confirm. Anybody? Anyone? So I'm talking about the system design and architecture for a backend I developed for a client in Ghana. Okay, system design and architecture. And before the interruption, so for those of you who have maybe watching this after the live stream, you can skip ahead if you watched the first part. So I talked about the requirements, the functional requirements, and non-functional requirements. For the requirements, I said we have to register assets. Okay, we have to categorize assets, and an asset was a physical asset or a tangible asset, not intangible assets like maybe stocks, nothing like that. Only things like maybe your vehicle, your IT equipment, your laptops, okay, your generators, SA units, and so on. And then tasks are required to be scheduled, okay, and tracked against these assets. Then you needed to notify a user before a task's due date, okay, via SMS and via email. After that, we needed to do reports, okay? A dashboard need to do, actually not, in fact, reports is maybe a misleading word because, but I think it's still a report because they are charts with a lot of information, okay? Having weekly trends, okay? So this should be trends. Let me put it in the familiar color. So the API was supposed to deliver weekly trends, okay? Also supposed to talk about and display overdue tasks, the number of overdue tasks in a week, in a day, in a month, okay? And supposed to distribute assets according to their categories. Then users are supposed to be managed according to their roles, okay? Different roles. Then for the non-functional requirements, in the worst case scenario, the API responses should have a latency of 500 milliseconds. And then 99% of the time, it should be available. The cost should be minimum because this is a startup, okay? There's no DevOps team, okay? So the client needed a pay-per-use app service, okay? Where they can only pay when they are using. Then after that, the application should be able to scale from tens to hundreds, okay? But I designed it in such a way that it can even scale to thousands. All right. Then after that, I can go down here. I began talking about the high level architecture. Okay. The client is simply a single page application, an SPA, built using Next.js. And I said at some point the front end developer fell sick and we were supposed to deliver. So I was forced to do about 98% of the front end integration. Okay. This is good for you to know. You may work for a startup and yeah, you may need to step up and fill in a role that you do not expect to fill in. Okay. And the client, this single page application sends requests via HTTPS to an API gateway, which is the AWS API gateway. And the request doesn't go from the Next.js frontend to our API directly. No, it is via the API gateway. Okay. Then from the API gateway to Lambda. You get it. Okay. And AWS Lambda, we deploy to it using our tool called Zapper. Okay. Of course, not our tool, but a tool called Zapper. And I showed you their GitHub repository. Okay. They describe it as a tool which makes it super easy to deploy and build serverless, event-driven Python applications. Okay. On AWS Lambda plus API gateway. Okay. and it has infinite scaling. This is why I told you I think it can scale to 1,000 requests. Okay, zero downtime, zero maintenance. Okay, no need to maintain. Okay, and it's very easy. Okay, as simple as this. In case you had a hello world application in Python, you simply say you install Zapper, say Zapper init and Zapper deploy, and you'd be okay. But of course, they mention it here like this, but it's not actually as easy as they say here, but it's much easier than doing an EC2. That is all I can tell you. All right. So Risk, if you're still here, please let me know if you now get it. Okay. Then we have CloudWatch for our events, okay, for our scheduled events and alerts, okay, so because every midnight we had events or notifications being sent to users via SMS and email, okay, and we're using CloudWatch. Think of CloudWatch as a cron job, okay. Then we have RDS for our Postgres database, then SMTP for the email, then the S3 bucket for our assets like images and static files, like and stuff like that. Okay, why Lambda? Low cost at low traffic, okay, compared to things like EC2 where you need to spend like, at a minimum, we calculated we might have to use around 30, okay, to $50 minimum per month, okay. But for Lambda, between $0 to $5, okay. So Lambda makes it to pay per invocation, and that makes it very cheap, okay. Also, scaling is automatic and instant with Lambda. But with a traditional server like EC2, it is manual. You have to set up things like auto scaling groups. Okay. Even the operational overhead, you have to many times SSH into your server, do some patches, monitor. Okay. Set up monitoring. But with serverless Lambda, it is zero server management. Okay. Yeah. And for cold starts, we mitigated it using Zapper. Zapper has a configuration. Okay, to help you mitigate cold starts. I think it's called keep warm. I'll mention it later. Okay. Then for regions, for both of them, you can pick in a region. Okay. So now I was going on before Risk asked me what I was talking about. I was going to now explain why we chose Postgres. Okay. All right. So to explain why I chose Postgres, I'll copy this, duplicate it. Okay. Bring it down here and explain every database that we looked at, okay, and then also share with you uh, the the reasons, okay. All right, so let's get into it now. The first DB, okay, we considered was uh, sometimes have you ever run out of words? It was DynamoDB, okay. So when I researched about, I need bullets. When I researched about this one here, DynamoDB, let me check again to make sure everything is okay. Okay. So why DynamoDB? Okay. You may be thinking, we just looked at DynamoDB, and in the research, I saw that it is the most natural database for Lambda. Okay. But the issue is this. We had two issues. Number one, our data is highly relational, like you're going to see when I show you the schema. And also, the DynamoDB has what they call, is it a single table design? Okay, it's what I I saw. Okay, but I think for this domain it would have been over engineering. Okay, and also another reason, I didn't know the number DB, neither was my colleague. Okay, all of us knew SQL. Okay, number one, our data is highly relational. We're reading that the number DB has a single table design. Okay, we're like, what the hell is this? And we knew SQL. So because the data was highly relational, okay, and the team, I and my colleague knew SQL very well, we're like, no, we're not going to do DynamoDB. Okay, all right. Now the other alternative we looked at was MongoDB. Okay, and like MongoDB is a NoSQL DB. Okay, but it wouldn't give the transactional guarantees which we needed for task updates. Okay, with notification scheduling. We had in Django there's something called transaction.atomic. Okay, it's a pattern called transaction.atomic. But simply what it does, it makes sure that all business logic, okay, that is wrapped under it, in the event that any failure happens, okay, the entire chunk is rolled back. The entire transaction is rolled back. Okay, so all the logic you have in that block of transaction.atomic is treated as one transaction. Okay, should any line of code fail, okay, everything is rolled back. So we didn't have that kind of guarantee. Okay, so like this pattern, which is transactional atomic, being used in services would be impossible. So we didn't consider MongoDB. Then another thing we looked at was MySQL. Okay, MySQL. So for MySQL is a very good option. Do you know that? MySQL is a very good option. We are both used. I have used it a lot. Okay, my colleague also used it a lot. Even the front-end developers used it a lot. But the challenge with MySQL is that we didn't want to go for it because of the UUID support, okay, that Postgres had. Okay, so Postgres SQL or SQL has better UUID support. Okay, and it has better JSON-B, okay, fields. Okay, and I can say Postgres is the Django community standard. Okay, because we're using Django. For those of you who have done Django, you'll agree with me that Postgres is the Django community standard. So we stuck, okay? We stuck to using Postgres, okay? Yes. Then of course, if any of you knows Django applications, they always come with SQLite by default, okay? And this one we saw that it's not viable for concurrent Lambda invocations. We're like, nah, no way. So this is how we ended up with Postgres, okay? Now I want to talk about the schema decisions. So I'll copy, how can I copy? Copy, paste, okay? And then I'll say key schema decisions, okay? Maybe I should reduce the scale of this a little bit. Just scale down a little bit and drag. Because I want it to be visible properly. So what are the key schema decisions? For the schema, this is what we did, okay? I'm going to go through the major tables. I can't go through all. There are many, trust me, by the way. But I want to go through the major ones. Now, the first one, of course, is the user. Okay, we have the user. So let me create this simple. Should even be smaller. Okay, let me start. Okay, I'll do the box after. So we have our primary key field. Okay, primary key field, which is an ID. Okay, so it's the primary key, uniquely identifying this row, or every row rather, or every user, and this was a UUID. Okay, I'll touch on this. Then we have another unique key. Okay, a unique key. So we had, of course, a primary key is also a unique key, but we had an additional unique key, which was the email. Okay. Then this user had things like permissions. Okay, we'll track their permissions. But permission is the best thing to say, not permissions, but permission. Okay. Then we also tracked temporal login fails. Okay. Temporal login fails. After that, we also have permanent login fails. Okay. Permanent login fails. And then there was a flag for tracking if a user has been blocked or not. Something like this. Okay. In fact, some people can make it better. Okay. I'm just thinking about a better way of doing it right now, by the way. Instead of having is blocked, you can have something like date blocked. Okay. So think of this as our user. Okay. I hope that makes sense. Rick says, so you are using RBSC for permissions or row level permissions. Yeah, we're using RBSC, role based access control. Yeah, good question, Risk. Um, but what do you mean by role level permissions? I'm just asking a follow up question to make sure I've understood what you're talking about. I need to know your understanding of role level permissions. Okay. Then after that, this user, of course, had a relationship with number one. The first thing was their preferences. Okay. I think I should use one of these boxes. Okay, to make life easy instead of writing. So I'll copy this here. Okay. So here we have a relationship. I'll copy all this and delete. So we have notification preferences. Okay. And this was a one-to-one relationship. Let me do this. That box can't have a border. So I think I have to just draw it like this. So a one-to-one relationship. Risk, I now understand. You're saying restrict database access to specific rows of data based on user roles, identity. No, we didn't do that. Yeah. It is simply RBSC, like you mentioned. Yeah, that's what we're doing. So between a user, okay, we're a one-to-one relationship, okay, between the user and the notification preferences. Let me go to the next line. So on the next line, I'm going to simply go through the fields. Of course, we have a PK, okay, which is the primary key, okay, and it's called ID, and it's also a UUID, okay. Then we have a foreign key, okay, which is a user. And like I said, it is a 1-to-1 relationship, okay. Then we have a field tracking the type of notification. Is it an SMS? Is it an email? Okay. Then we have a time unit, then time value. Okay. So time unit means, let me explain with time value. Time value means, is it, no, time unit means, is it a week? Because we had the client wanted either weekly reminders, okay, or daily, okay. So you'd say, I want maybe weeks, okay. I want it to be in terms of weeks, okay. And the value would be 2 weeks, okay. So 2 weeks before an asset is due, you give me a reminder, okay. Or you'd say maybe days, okay. Then it would be 2 days before, okay, or 1 day before, okay. I hope that makes sense. All right. So what else? What else? What else? Let me see the chart. Be easy to drag my chart this other side. All right. Then after that, there was, let me drag So we have notification preferences. The next one, just copy and duplicate this, is what I can call user activity. Okay, so we had user activity. So I'll remove this and so we have a user activity. Okay, and for user activity, we have the following. Okay, we have the same thing, a primary key. Should have just copied from the other one, ID, which is a UU ID, then foreign key, okay, to the user table, okay, and this one was a one-to-many. Then we have things like the module, okay, uh, action, okay, the device, okay, IP address, okay, then lat long, okay, just short form for latitude and longitude. I think this is it, if I remember well. Okay, so I can just put this in a simple box. Okay, so this was the user activity, and this was a one-to-many relationship. Okay. What else? We had now the assets. Okay, can paste and edit this. Okay, we have the assets. So for the asset, we have. Let me go to the next line. We have the same things on this other end. Wow, this is too big. How can I reduce this? Sorry. But I hope this is visible. Let me check. So it means alerts, right? What do you mean alerts? Alerts like risk? Are you talking about like alerts for like the alerts? Yeah, alerts. I understand you now. Yeah, alerts for the tasks. Okay, like if a task, let's say you have a fridge, okay, and that fridge is to be maintained, uh, maybe according to what you want. Okay, you may say that I want to be reminded 2 weeks before my fridge is going to be uh, repaired, okay, or maintained, something like that. Yes, you're right. The time unit. That you're right. Or stuff like maybe I want to be notified 2 weeks before the fuel. Maybe in your generator, you know that the fuel gets done in maybe 5 days. Okay. So you want to be alerted 2 days before the fuel gets finished in your generator. Yeah, that was the purpose of the alerts. And these alerts will be sent every day at midnight. So every day at midnight, we simply check. Okay. We had a like CloudWatch. On CloudWatch, you have like a cron job, okay, which fires, okay, a request to our Lambda to simply check in the database. Is there any event, okay, that fits this requirement that it's the due date is maybe uh due maybe like in maybe 2 weeks or days. Okay, so we simply use the days and weeks. There's nothing like maybe hour or minutes, only that. Yeah, so for the assets, this stuff is still big. I need to reduce it. Reduce, come on. Okay, yeah, I think this is small. Big. I hope you can. Yeah, it's still visible. So for the asset, we have the same thing. So I want to copy. Wow, it's hard to copy the whole thing. I'll just type it. Okay. So for the asset, we also have a primary key, which is called the ID field. Okay. And of course, by now, I'm sure you notice a UID. And then we have a foreign key. Okay. Called, um, you can guess. Let's call it owner. Okay. Who owns this asset? Okay. To the user model. And we had a one-to-many relationship. Okay. So this asset, of course, it has a name. Okay. We had the category. Okay. This category had about, I think, 10 types. Okay. So we had default 10 types. So the client could not create categories. Okay. They already defined. Okay. When we asked them, do you want to be able to add categories? They said no. So we're like, it's okay. And it would have been actually a good feature to have. Then the asset condition. Okay, we had an asset code. Okay, and this was by the automatically generated. Okay, then we had an image. Okay, and of course this image was an S3 URL. Okay, we were not storing our images in the Postgres database, so we'd have the front end upload the image directly to AWS S3. Okay, like if you remember the higher level architecture, I talked about S3. Okay, so the front end uploads directly to the S3 bucket. Then we get the URL, okay, and then save it in the database using the API via the backend. That's what we did. So I'll simply draw my box here. Okay, where is the user model? So yeah, so again, also here, a one-to-many relationship. Yeah, so that's, yeah, this is how it looks so far. If I zoom out. Okay, let's move on. I'm seeing this stream has spent around 67 minutes. Okay, let me talk about maybe a few more. Okay, then let me talk about what is key. We had another one. Let me drag this here. I'll delete this and then say task. Okay, we got tasks. Okay, tied to assets. So for this, we have also primary key called ID and it's a UUID. Okay, we have a foreign key. Okay, which is an asset. Okay, then of course the name, then the status. Okay, like maybe it is maybe completed, it is in progress. Okay, it is maybe failed. Okay, then we had due, the due date. Okay, and then we had a is overdue. Okay, but this overdue was a computed field. Okay, I don't know if people in other tech stacks have computed fields, but I've worked in Spring Boot. I've worked with, I think, I worked with Spring Boot, Java, Django. I've seen computed fields. I think even Fast API, Express. I've never worked with a computed field in the world of Node.js, so I'm not sure if they have that stuff. Okay, but it is a computed field against the, what is it called, against the due date. Okay, so we pre-computed is overdue. My spelling is wrong. Okay, are you also using catching, like, oh wow, I don't know how I forgot. Yeah, we're actually catching. Thank you, Risk. In my architecture here, I should have put catching. Okay, so we have here for common requests for common assets. Okay, we catch them. Okay, yeah, we put here catch. Okay, yeah, thank you. So I guess by your questions, I'll remember a few things in the high level architecture. But let's go down here, back here. Okay, then I'll draw a simple box. Simple box. Wow, this box is ugly. Shouldn't put many corners. We had a catch, but I don't think it was Redis. Okay, yeah, give me time to think. It was not Redis actually. Then I'll, yeah, put a relationship. So between an asset, it was a one to many relationship. The other one I can talk about is the notification. Okay, so I can come here, paste. Okay, drag it, select all, delete, and say we have notification. I don't know if I had I think I have notification preferences. Yeah, it is here. I was going to wonder. So for notifications, of course, the usual. Okay, it has an ID, which is a UUID, foreign key, called task, okay, because the notifications were for task, and of course, this is a one-to-one relationship. Send at, okay, come on, this has to be lowercase, not uppercase. Send underscore at, then send, okay? Yeah, that's just a boolean. So I'll draw a box. I need a pen, draw a box around this, and then indicate that this is a 1, 1, 2, 1. Yeah, so that's what happened, okay? You may be asking, why are the primary keys all UUIDs, okay? They're UUIDs because we're trying to prevent sequential enumeration attacks, okay? I think they call it, is it IDOR, okay? Where the I is, this, I don't know if you guys know this. Do you know IDOR? There's an article I saw. I'm trying to look for it. Insecure direct object. This. Uh, I can't see it. I want to share with you a very nice article. Okay, but okay. ID. What is this in full? Okay, the I is for insecure. The D is for direct. O is for object. R is for references. Okay, it's a security flaw. Okay, whereby in case, for example, I knew that you're using maybe IDs. Okay, like integers. Okay, and I see that maybe when I'm logged in, my ID is 1. Okay, ID for something is 1. Okay, I can simply change, say ID equals to 2. Okay, and access data. Okay, and view. I can view, and if I see that I can view data just by doing this. Okay, I can attempt to modify it and delete sensitive data or block other users. You get, yeah, this is the attack. So that is why we went for UUIDs. Okay, yeah, we went for UUIDs to prevent this IDOR kind of attack. Okay, yeah, because if an attacker sees this kind of an attempt to say, okay, so I was able to fetch an asset with ID2. What if I tried maybe a user with ID equals 3? Okay, and if results are returned, the guy can celebrate and just go ahead to maybe do anything malicious. Okay, yeah, so to prevent this sequential enumeration, we chose UUIDs. Okay, yeah. Okay, yeah, Risk, I'm happy that you now understand it. Okay, awesome. Yeah, so that is for the schema decisions and where I used UIDs. Yeah, even better UIDs are also safe when you have a distributed system. Okay, there's nothing like maybe in this other part, in maybe system A, there's a user with ID1. In system 2, there's a user with ID1. Okay, you don't have this kind of things. Okay, yeah, so it also helps you to avoid auto increment conflicts. Okay, in case you have several, of course, lambda infects, not effects, but instances. So I think for the key decisions, this is it. Let me go on to something else. Okay, yeah, some of the things you can talk and talk and talk and never get done. Where I come from, they say you can talk until the cows get back home. Let me drag this here. Okay, and say now I want to talk about the API design and layered architecture. I need to reduce this so that you can see it. Let me see, what can I do to this? If I expand it, okay, then I hit, wow, the word architecture is still, let me see. On my side, it is hidden, but I don't know if you can see it on your end. It is still hidden, so I can put it on the next line, okay? Shall achieve the same purpose. So draw that and also draw here. Risk is saying, I had one question. Suppose I change permission of one particular user. How will that update? How will that update quickly so that user doesn't get problem with their permission revoked? Are you talking about the attack I mentioned? Like if you got access to a person's uh person's maybe I don't know their ID and the system is weak enough that using an ID can update a user's information and you change their role from maybe from admin to just a normal client. Okay. How will that update quickly? So that the user. Okay. So what happens is this. Okay. Let's assume you're using normal REST. Okay. There's no WebSocket, no live changes. Okay. If you attacked the database and you change their role to admin. Okay. And for example, you're using a JSON web token. Okay. Remember, JSON web tokens are verified in the backend. Okay. They are verified. For example, if you hash it, if you generate a JSON web token and you hashed it using the user ID and their role, okay, and maybe for the current page which they are viewing needs the role of admin, the next time they request any action, okay, the backend will extract the token, okay, and first of all check if the token is valid, like it's not malformed. Secondly, to check is this token expired. If it is not expired, the next thing will be to check and extract the ID and the role. When it extracts them and sees that the ID, the role is now client, okay, it throws back a 401 unauthorized. And what happens? The front end picks that and it closes out the user, loses access. That's what happens. But now you who hacked, okay, you now have access to the system. You can now log in, okay, and perform activities as a admin. Because why? All your JWT tokens, okay, will be authenticated perfectly well. I hope that explains it properly. Yeah, but that's what would happen. If I've not understood, please, yeah, you can ask a follow-up questions if I've not explained it well. Okay, let's talk about the API design. But I'm waiting for the question just in case. We need to talk about API design. Okay, yeah, I'm very happy you've understood it. All right, let's go on to the next thing. So for the API design, yeah, I'll just talk about the bare minimum, okay, bare metal. So we had our, like I told you, we're working with Django, okay. So this is how it works, okay. Assuming you have, so I want to copy and paste a few things to make life easier. I'll copy this, then come here and paste, okay. So I'll remove all this. So we have our HTTP request, okay. The HTTP request, okay. Then I'll simply draw a box around it. Again, HTTP request sent over HTTPS, remember, okay? So you send us a request over, okay? Now this is now inside Lambda, okay? I'm assuming we're now inside Lambda, okay? This is now what the actual developers now created, okay? This is what I actually created, okay? We have in Django, in Django API layers, okay? For those of you who do fast API, Node.js, think of it as can I call it a route handler? Is it? I think in Express that's something. Okay, in Express, think about a function which is given to your Express route handler. Okay, but in Django we call them views. Okay, but the whole concept is that it is simply a function or a class which accepts an HTTP request and returns the response, which is the concept everywhere. Okay, accept an HTTP request, return a HTTP response. As simple as that. Okay. Yeah. And in Django, we simply call them views. Okay. Yeah. Just a technical, opinionated term. Okay. Yeah. So this is the API layer. It's the first API layer. Okay. So where we have the what I can call the HTTP handling. HTTP handling. Wow. I'm writing while going up. Did you see that? I was writing while going to the sky. So HTTP handling, okay. Auth, okay. We had helpers helping with things like the response, okay. But to be specific, I need to say response formatting, okay. Response formatting, okay. Then we had another layer, okay, built on these on these views, okay. I want to copy and duplicate this and drag it down here, okay. What we call the selectors, okay. Okay, just again, this is just technical jargon, okay. So from the view, a view either interacts with the selector. Let me just give me a moment. I need to drag. So a view would either interact with the selector or with something that we called a service. Okay, we had services and selectors. Okay, and sorry about that. What is a selector and what is a service? A selector was simply a function which is responsible for reading. Okay, like reading maybe from a CSV file or reading from our database, in this case, Postgres. Okay, for making reads. Okay, and a service, okay, was responsible for writing. Okay, so we had functions which were responsible for only doing write operations and services responsible for only fetching from the database. Okay, that was the separation of concerns that we had. Okay, then after that, each of these interacted via an ORM. Okay, they made request to the database via an ORM. In this case, we use the Django ORM. Okay, and of course, finally, here at the very bottom, we have the Postgres. PostgreSQL. Okay, as simple as that. You get. So just to summarize, okay, views responsible for HTTP handling, authentication, and authorization, response formatting. Okay. Then selectors for read-only queries with filtering. Yeah, I forgot to add that. We had filtering also. Then services for write operations with business logic. Okay. And we had something by the I forgot. But no, I mentioned it. Yeah, I mentioned it. I thought I'd forgotten. Let me copy and sorry. Just come and copy and paste. What I told you earlier on. Okay. I mentioned in Django we have something called at transaction, okay, atomic, but in any framework you use, okay, the concept is the same. Let me just explain it. Okay, the concept is actually the same. So if you had like your block of code, okay, block 1, okay, you have line 1 of code, another line of code, another line of code, okay, maybe each of them is doing several operations, different operations to the database. Okay, once you wrap it with this transaction atomic, okay, and maybe line 2, okay, line 2 failed, okay, let's say line 1 passed but line 2 fails, okay, all this operation is considered a failure. It is rolled back. The operation of line 1 which passed is rolled back. Or line 1 works, line 2 works, line 3 fails. The whole thing is rolled back. It is only considered a success when all of them succeed. Okay. Yeah, maybe something I forgot to talk about. We had serializers, okay, somewhere, but they're simply responsible for serializing and deserializing. Risk has a question, says, so you also using read replicas and read for utilize the service or single DB is enough for now. Yeah, we had read replica, okay? 2 read replicas. You're asking really good questions, okay? So we were writing to one database, okay, and reading from 2. Yeah, but actually after some time we shut down the replicas because the volume of transactions did not merit that. Yeah. In the beginning, 2 read replicas and 1 DB, the master, okay? Some people call it master slave relationship. Yeah, but in the end, we just used 1. Okay. Later, if we need, then yeah, we can set up auto scaling. But right now, the 1 was working perfectly. Okay. I hope that answers your question. In case you need, you can ask. Then there's something nice, which I did for the first time. Okay. I got it from something. They call it the Django Hack Soft style guide. Okay. I loved it. Okay. Actually, I copied this and told the LLM to always format my API layer using this guide. Okay. I won't go through it, but you can check it out in case you want it. Okay. But what I got from it was that I would have serializers. Okay. And I told you a serializer is only for input, validation, and output formatting. Okay. Their classes are used for output and input formatting. Okay. And validation. But in this style guide, I learned that it is good thing to separate what is responsible for validating the input and what is responsible for, because in Django, you can decide to have one class, okay, which can do that for you, both for input and output, okay? But then I had what is called an input serializer responsible for input validation only, okay? Then I had what I called an output serializer, okay, which is responsible for read-only output, okay. Then also I had another serializer responsible for partial update validation, okay. And it makes sense because the fields which we most times use when we're doing things like creations, okay, creating resources, they are different from what you return. For example, if you are doing a post request, you don't need a date created field in the input, okay? But in the response, you need a date created field, okay? So yeah, it simply helps you to prevent overposting vulnerabilities, okay? And makes the API contract very clear. Yeah, so there are endpoints I'm going to talk about. I won't talk about all, okay? I won't talk about some, okay? Yeah, because some are like I don't want to end up leaking business secrets. Okay. Yeah, I don't want to end up leaking business secrets. So I'm going to talk about some of the API endpoints that I'm sure even you who's watching you can guess that they existed. So I'll copy and select this, copy this, come down here and paste. So I'll rename this. Come on. API endpoints. Okay. Then again, I want to copy something. Come down and paste. Okay. So this is the API. We had the post, okay, for slash APIs. I think it was users, but this one was for registration. Okay. It was also by the it was rate limited to anonymous users. Okay. To 5, I think it was 5 minutes. Yeah, I think it was 5. Yeah, it was 5 minutes. So it had a rate limit. Okay. Even for other endpoints, we have other rate limits, but this is the one that, yeah, I remember adding fast. Then we had another post, okay, but this endpoint was for. I'm just going to short form them, okay. Say dash dash dash. We had one for setting passwords, okay, and this one was a token based password setup, okay. Then we had one for providing tokens, okay. Think of this as our JWT login. I don't know if this is big enough. Let me expand it just a moment. Expand it. Okay. So login lowercase. Then there's, I think, another. I'm sure you've already guessed. There's another endpoint. Okay. For a refresh JWT. Refresh JWT. Then we had a get and put. Okay. For your profile. Yeah, simply sure you again, you guessed it, to help you either view or update your profile. Then I think we had something similar, get put, okay, for your notification preferences, okay. Let me just abbreviate it, not underscore pref, okay, prefs, okay, for notification settings. What else comes to mind? There was a get and post for something concerning assets, okay. By the way, there was no. This is of course for listing and creating. Okay, let me just put it here. Either create, okay, or listing. Okay, and the listing involved either a search or filter. Okay, then what else comes to mind? Then there was a get, put, delete. Okay, concerned with still assets. Okay, assets. I hope it's clear. Okay, so asset detail operation, get one asset detail, put or delete. Then I think there was also a get, just the common ones. Okay, let me see what else. Tasks, yeah, for tasks. Okay, then in a similar way, a get, put, delete. Okay, for also tasks. Okay, and of course you know that you have to pass we're passing the UID. Okay, the UID. The same thing for also assets. Okay, UUID. Then we had one endpoint, okay, which was responsible for giving the report on the summary, okay. It was like an aggregated dashboard data. Wow. Yeah, so that's it. Then another thing I can go to and talk about. Yeah, so for the authentication flow, I think that is can I say, do I need to talk about that? Let me just the time check. I want to make sure I don't over spend time here. Yeah, so for the authentication and security, this is what happened. Let me copy this. Just go through the normal, the auth flow. So this is what happened for the auth flow. Just a moment. This thing keeps hanging. I hope the stuff is working on your end. Let me just confirm it. Just confirm it from another device. I could be thinking it is working, and yet I'm instead in my own scam. Okay. I don't want to get, yeah, looks okay on this end too. All right, let's go ahead. All right, so for the auth flow, it's very simple actually. Very, very simple and basic. So I'll give it maybe an auth flow, good session, learn a lot, good session. I've learned a lot of things about system design. Oh, that's good. Yeah, such messages, yeah, make me want to do a lot of this. I appreciate. Thank you. All right, let's talk about the auth flow. I think I'll talk about the registration and password flow. Yeah. So I'll go with an admin, okay? An admin. So if you had an admin, okay? An admin, what would they do? An admin would simply, let me just draw like, if I can try to make a dashed line. Okay, so an admin, okay, sends a registration, okay, a post request to register. Okay, they send this request with their email and name. Okay, so let us assume this is a slash register endpoint. Okay, so as this, when they send this request, do you know what happens? Okay, of course, I wanted to use dashed lines for the components. Okay, then they request a full line. Okay, so let me put here an API. Okay, let me put here another boundary to represent the catch. Okay, risk is what you asked me about earlier. Okay, then I can say email service. Okay, so let me just say email. Okay, no need to write service. Okay, all right, so register with email and password, okay, to the API. Then in the catch, okay, after, in case everything is okay, okay, the email is correct, password is correct. For those who might be joining at this point, let me put in brackets. It won't work out. Okay, let me just continue. Okay, so you register. When you hit the registration endpoint and everything is okay, okay, we store the token. Okay, so the token is stored in the cache. Okay, and we decided to store it for 24 hours. Okay, 24 hours. Okay, at the same time, okay, we send, the API sends a request to the email service. Okay, draw a straight line to the email. Okay, the email service. Okay, to send a set password link. Okay, set password link. Okay, this is what happens. Set password link. Okay, so of course, if you remember, this thing can expire. Okay, so I'm assuming the user has clicked. Okay, when it has not expired. Okay, so when they click, then they get back the application. Okay, they have clicked on the email with the link. Okay, I'll just say email, just say link. Okay, this is the link they have clicked on. Okay, so if they have clicked on this link, okay, they can now fill in their password. Okay, and another request, okay, a post request is sent to the set password endpoint. Okay, a post request, and this post request, okay, they'll send, it goes to the backend using the email. It includes the email, the token, and the password. Okay, of course the user does not enter their password again and the token. Okay, they only enter their password, and then the backend does a validation. Okay, after that's validated, a request is made to the cache to delete the token. Okay, remember I told you the token is stored for 24 hours. Okay, it is deleted. Okay. After the token is deleted, let me just put some dashes here. I think I'm done. Okay. After the token is deleted, the API now returns. Remember, this is the API layer. Okay. The API now returns, okay, two things. Okay. It returns two GWT tokens. Okay. An access plus refresh token. Okay. But in fact, in the coming weeks, I am going to change this to HTTP only cookies. Okay. Yeah. So yeah, I don't have time to talk about them, but I have a video. For those of you who have been following me on this channel, check the playlist where I'm building a flight booking engine. You'll see a video about HTTP only cookies. Okay. Yeah. So after that, all subsequent English is going to make me cry right now. I'm failing to pronounce the word subsequent. So all subsequent requests after this, okay, they use this GWT token. Yeah. So yeah, that's what I can talk about one flow. Another thing I can talk about, okay, before we wrap up, is simply I want to talk about how I handled latency. Remember, this thing is in Ghana, okay, and how I want to improve it. I want to talk about security layers, okay, and maybe how I designed the upload. The upload is actually very simple, okay, yeah, and maybe the CI/CD pipeline and how I would scale to 10 users, okay. So let's talk about uh, security layers. But security layers are actually not that many, okay. I want to copy and paste. Can I copy this? Okay, copy, paste, and drag it. I want to hide these other things because it's a new topic. Security. In fact, I think I've talked about a number of them already. Okay. So for security layers, I'll pick a different color. Okay, security layers. Like I've already have the authentication. I've already touched on that. Okay. We have authentication. Okay. And it is a 15-minute access. Okay. So we have an access token which expires in 15 minutes. And we have a 7-day refresh token. Okay. By the way, we also provided OAuth 2. Okay. So we have also provided OAuth 2. Maybe for the password policy, okay, it's a common one, which I'm sure all of you know, okay, which is minimum 8 characters, 1 uppercase character, 1 lowercase character, 1 digit, and 1 special character. That is what we have for our password policy. Then for brute force protection, this has to be lowercase. We simply used the model. Okay, we have I forgot to talk about a model. Okay, we have a model which tracks failed logins. Okay, yeah, we have a model which tracks. I created a model. Where is the database? Here. Okay, in this schema decision, I should have talked about a model called failed login. Okay, which tracks the attempts, okay, by IP address, okay. I check the temporal login fails plus temporal login fails plus permanent login fail counters, okay. And also have the is blocked flag. Let me show you that one more time. Where is it? Okay, so I have failed logins, okay, but how I track, I have a counter which counts the temporal and permanent login fails, and then I have this is blocked flag. Okay, I'll scroll down quickly. Okay. Then in addition to that, we have rate limiting. Okay. And like I told you for at registration, okay, we have 5 requests per minute. Okay. 5 requests per minute per minute. The other rate limit for other endpoints, I can't really remember, but we also have it. Okay. Then we have an audit trail. Okay. Again, I forgot to mention a table. We have a table. I think it's there. Yeah. a table for user activity, okay? Which logs the module, the action, the description, the device, the IP address, the country, latitude, longitude, things like that, okay? Then what is common, and I talked about it earlier, we have HTTPS, of course, okay? And secure cookies. We have also calls, okay? Configured. We have CRSF, okay? This is by default in Django, by the way. We have, I think that is it. Nothing else comes to my mind. Okay. So I hope I'm good with questions. So the next thing I want to talk about is latency, how I handled latency and the plan going forward concerning latency. Because like I told you, the application is used in Ghana. Okay. So like AWS does not have a data center in Ghana. Okay. Let me rename this to latency. Okay. So AWS has no data center in Ghana. And we put it in the EU region. Okay. We put it in the EU region. Okay. So how did we do that? Okay. Because I think of that distance, there's of course some lag. Okay. Some lag. I think around maybe, I don't know, is it 100 or 20 milliseconds? I need to verify that. Okay. So this tool that we use called Zappa, okay, had a configuration which I talked about earlier, okay, called keep warm. Okay. So we set this keep warm configuration to true to help us to eliminate many called stats. Okay. We had keep warm true. Okay. Then it has a config called keep warm expression. Okay. So keep warm true. Then the keep warm expression is like an interval. Okay. When it should monitor to help you keep your Lambda stuff on. Okay. Was a minute. Okay. So when you learn, if you're doing Django and you're interested in Django, you'll have to configure this in something called the Zappa settings.json file. Okay. Then another way to handle with latency, like I think I mentioned this earlier, on the client side, okay, the client uploads to S3 directly. Okay. Upload to S3 directly is the solution we had for this. Okay. Yeah. So we didn't want this to go through Lambda. Okay. Then the emails, okay, if the email sending was asynchronous, okay, because SMTP is really slow. Yeah, for queries we indexed, okay, many fetches, okay, and there's something I remember we put it called slim handler in the configuration, okay. But the goal was to only helps you to have essential code for Lambda. Okay. Yeah. I can't kind of remember other things. Then I think I can talk about the notification design probably. Yeah, so it's actually quite simple. And by now you can even guess what it is, what it looks like. Notification design. So what happens is, I'll give you an example, okay? A user, okay, creates a task, okay? Maybe a task which is due maybe 10th March, okay? Then that task, okay, of course, an API request is made, okay? The task which is due on 10th March, okay? And then the API, just do lines, just create boundaries, okay? Saves that to the DB database, okay? Okay, and as it does that, it calculates the send at. I told you we have a send at field, okay, in the task, okay, but it uses the the user's notification preferences, okay, to calculate or compute this send at field, okay, and then it creates also the notification, okay. So this is for creating the task, okay. This is for creating the notification, okay. And after the notification has been created, okay, immediately the user gets a response, 201, okay. After that, we have an async task, okay, that okay, that sends an email, okay, to a user that, you know what, uh, such and such a task has been created, okay, for this and this date. You get, okay. Then I talked about CloudWatch, okay. There's another tool called CloudWatch, okay. CloudWatch. For CloudWatch, every day at midnight, okay, daily at midnight, okay, Cloud will check triggers, okay, triggers a call to our Lambda, okay. I've run out of space, okay. Lambda is around here, okay. Triggers a call to Lambda, okay. Every day at midnight. You can spell Lambda right. At midnight, okay. Triggers a Lambda, okay. And Lambda, our application in Lambda, simply goes to the database, okay, to check for unsent notifications, okay. And the goal is simply to look at the send at field, okay. Compare the send at field to the current date and time, okay. Once it does that, okay, it then sends, Lambda now sends reminders, okay, in case that condition is met via SMTP, okay. Once it is sent, okay, then we make another request back to the database, okay, to mark them as sent, okay, mark as sent, okay. That's the design for the notifications, okay. And by the according to the user's notification preferences, it will either be a SMS or email. Then I'll talk about the upload. For upload is actually also quite similar. And copy this also. Wow, this stream has been long. Okay, I'm not sure if my other system design video was this long, but this has been long. I'm starting to feel next train. Just a moment. I need to move this closer. All right, so this will be for the file upload. So how did I do the file upload? Here it is. Put a dash, choose a color. Come on, I've lost that. Okay, I'm now back. So let me just use this box to type for the. So we have the client or the browser. Okay, copy paste. Okay. Actually, doing this is easier. So this is what I should have done from the beginning. Okay. So you have the browser, the client. You have the API. It has to be uppercase. Then you have AWS S3. AWS S3. Just drag them closer. All right. Now with this one, this is what happens. Okay. You get from the client, of course, sends a request to the API. Okay. Browser sends a request to the API having the name, okay, the name of the file, the type, okay, the size, okay, and the destination, the destination folder, directory or folder, okay, and the actual file, of course, okay. Then after that, okay, API, of course, validates, you get, and sends it to, no, sorry, I'm misleading you, this is wrong. We skip the API completely, okay, and go to S3, okay, yeah, you get. Then after that, from S3, okay, after this is done, okay, the the client should have been client instead of saying browser, okay. The client now gives the API, okay, the URL, okay, URL, okay, things like object key, okay, the object key, the URL of the image, okay, simple as that, okay. Then sends back saying, yeah, everything is okay, we have uploaded, okay, yeah, very simple, isn't it? If you have any question, simply ask. So the goal is this, I'll repeat, we have the browser or the client upload to AWS S3. From AWS S3, AWS S3 returns us information that is the URL of where you have stored your image. After that, the client sends a post request to the API to save this image. Okay, and the API returns a 200 okay. As simple as that. Okay, yeah. So uploading directly to S3 is much faster and actually saves time. Okay, yeah. So the API only stores the resulting S3 URL. What can I talk about? I think I want to talk about the dashboard. I can skip the dashboard since I touched on it earlier. But the dashboard only covers things like reports concerning like total assets, total tasks, overdue tasks, failed tasks, assets by category, tasks by status, weekly trends. Okay, and we look at the past 7 days only. Then maybe I can talk about this CI/CD. It should be lowercase CI/CD pipeline. I want my titles in white. Copy, paste, and reduce its size. So for the CI/CD, we have, of course, wow, I've lost the stuff. We have the GitHub. I'm using GitHub Actions. I can't spell GitHub. Isn't that surprising? To be a developer who can't spell. Okay. So with the GitHub Actions, first thing what we have, okay, we have a health check job. Okay. Let me, sorry. We have a health check job. Okay. Then this health check job, you know what it does? It simply spins up Postgres DB, PostgreSQL. After spinning up the DB, okay, we install dependencies. Okay. To install dependencies, can spell dependencies properly. After installing dependencies, okay, we does a migration on the database, okay. Then does simply a check, okay, a check just to simply know that things are okay, that things can compile properly, okay. After that, if this passes, okay, if this passes, just want to draw a box around this because yeah, I'm an artist for now. All right, so if this has passed, okay, so I'll say pass, okay. When this passes, okay, copy and paste, drag. When this passes, now there's a deploy job I configured, okay. What is this one responsible for? First of all, starts by configures AWS credentials, okay. And this is typically what you do for a simple project like this. Okay, of course, not simple, but yeah, it's not very complex, okay. Then yeah, does the same thing, okay. Installs the dependencies, okay. After installing dependencies, okay, it does a detection, okay. Are we deploying for the first time, okay, or are we making an update, okay. So if it is an update, if it's the first deploy, okay, it is new, okay, we deploy, okay. Zapper has a command called zapper deploy, okay, we deploy, okay. If it is existing, okay, that is zapper tool I talked about, simply does a zapper update, okay. Then after that, we the usual migrate, and yeah, the server is spins up, okay. Yeah, so as like by now what pipelines do, the goal is to automatically determine whether to deploy for the first time or update, okay, which is simply a subsequent patch, okay, making it what they call idempotent. Yeah, so I want to wrap up. I could be here, I can talk about this forever. I like system design, I like talking about designing systems. If you've enjoyed this, please share it with people in your network, okay? Like this video and share it with people in your network. Okay, let me see. Who is this? So if you like this, let me know in the chat after the stream, okay? I can make more videos about system design. I can even start a video, say a series saying what is system design, and go topic by topic, topic by topic, topic by topic, okay? All right, so what would I change, okay, if we were to improve this project, okay? What would I what would I change? Okay, in case the lambda, let me pick a title here, okay, copy and paste. What can I improve if I was given a chance, okay? So what I would change, okay, maybe assuming now the application has scaled to 10 times, okay, 10x scale, maybe you're handling thousands of users, okay, and it has become crazy. It's disturbing, okay, it's stressing me, okay. I would think I would move, if like the lambda cold starts became a problem, okay, I would move to ECS, okay, yeah, to avoid maybe the lambda cold starts. Let me change the color of this, okay, and reduce the size a little bit, okay. So I move to ECS, Then something, actually, if you've been keen, okay, I did not, Risk asked me about catching, okay, but actually we're not using Redis, okay, we are using local, is a local mem catch, okay, on Lambda, okay. But right now, what I would do, okay, I would move, okay, for session catching, maybe rate limiting, and maybe notification queues, okay, okay. I'd actually add Redis, okay, I would add Redis. Then for the reports, the dashboard, okay, I would pre-compute, because right now they are computed on request. When you make a request, then they are computed, okay. But I would pre-compute them, okay. And maybe I would have a job, a scheduled job, maybe every day at midnight, which writes, okay, dashboard data to a snapshot table. So I'll have like a table for having snapshots of maybe weekly trends, failed tasks, past tasks, overdue tasks. Okay. Yeah, that's what I would do. Then I would maybe attach, in case maybe we had so many static assets. Okay. I would put a CDN. Okay. Yeah. CDN. Then also I think I would deploy, okay, a replica, okay, in the South Africa region, okay. I think it's called, is it AF South 1, if I'm not mistaken, okay, because I think that region is in Cape Town. So I think Cape Town, that route between Cape Town and West Africa is very close, okay. I think it would be faster than the EU US West, okay. Then I would have event driven notifications. Yeah. Also, by the API versioning, I didn't. This seemed like no issue, because it's basically one client, and we saw nothing like this changing. Okay. So yeah, I would just simply. I think it would be a nice thing, even if we don't expect like several, or just a one-off thing. But I know it would be awesome to have API versioning. Okay. Mm, what else can comes to mind? Yeah, so I think that's basically it. Okay. Because yeah, the client had a small budget, client had no DevOps team, but person wants the application in 6 weeks. Okay. And wants to spend at most maybe like $20 in initial server costs. Yeah. So Lambda comes to the rescue, because the account they create on AWS initially is a free tier. Okay. Yeah. Yeah. Why? Serverless is nice, zero operation cost. Okay. And the team is small. Yeah. Postgres SQL, it's the thing in the Django community. Order is highly relational. And we on the team know SQL very well. Okay. S3 Direct, why? The Lambda cannot handle file uploads like really well. So yeah. And S3 is also globally distributed. We used Zappa. Okay. Yeah, Zappa async for our async tasks. Okay. We didn't need Celery for that. Yeah. There was an issue with it was tough configuring Celery, okay, on Lambda. Okay. UID PKs, for the reason I told you about, the attack I told you about. Yeah, so yeah, the system works, it's in production, and it can grow. That's the main point. So appreciate everyone. Risk, you've been a very active participant. I appreciate your questions. They've been really thoughtful questions. Thank you very much. So bye for now. Thank you for everybody who has been patient, okay? Especially when I had that challenge with my network. Catch you in the next video or live stream. Bye for now.